Loop engineering, graph engineering, harness engineering, and Evals evaluations for AI agents are some of the biggest AI agent buzzwords right now. But they didn't go viral and became popular because they are complicated or magical. They're actually very simple building blocks. I will take you inside each one and show you how they help us build most intelligent agentic system that work in the real world. You don't need any background, just stay with me. So let's walk through them step by step using real code from prompt and context engineering to production AI agents. I promise you, loop engineering will surprise you. So let's start with the first layer. But before we do, let me bring back the production insurance claim agent team from my previous video, where I built 5 agents end-to-end. We will use this system throughout the video to see exactly why each engineering layers matter. Imagine this, the damage is minor, but the system approves a 4,500 payout. The 5 agents run, the graph completed, and the answer is still wrong. Now a human has to inspect every trace, change the logic, and then run the whole agent claim again. This is the gap that these new engineering layers are designed to solve for prompt engineering. So for our insurance problem, we could just use a prompt like a vision prompt to say you are a vehicle damage document assistant and give some clues, what kind of guidelines they need. And this is basically that prompt engineering. We give some role task constraints, formats, and then LLM will just give us a reply. And we need to just have clear prompts. The problem is that it's one shot. You can just do a loop and iteration, but it does not solve very big problems. Plus, we need basically context. That's why we need context engineering, the next step. And if I look at my AI agents and I look at the claim state, the input of my model is that claim input. It has policy, customer, incident, damage, everything that we can feed in as context. So then we can do this damage evidence assessment or policy decisions or risk assessments. Of course, finally, just payout recommendation. That's what we call context engineering. Anything that we have, we put it on context and we give data. And as these context windows get very big, more and more will fit there. But there is this risk of oversimplification because we are dealing with a context rot after about 10% of this very big context window, which was explained about ChromaDB. After that threshold, basically, it's going to make a lot of mistakes. In my video about advanced context engineering, I've talked about 7 advanced methods, offloading, context compaction, agent as a tool. But still, the limitation of context engineering is that we do not know for sure that the agent is going to do the task reliably. That's why we need the next layer, which is having this agent execution. In our insurance project, looking at intake agent, you will have the claim type. We'll go through the process of normalizing, validating, then require statement dependencies, then building evidence from the validated fields, then the damage evidence presence, then customer estate length, prior claims, late reporting, drive confidence, and intake complete, and audit event. As you can see, there's a lot around that agent. So it's not just one agent doing the task, but we are making sure that the agent does exactly what business is asking it. So we always choose a pattern like React and just reason, go do some actions, we observe, we get feedback, we replan or retry and stop when it's complete. Otherwise, you will do through the whole process. In this stage, we want to answer how should one agent really act in all of the situations. And we want to reach better execution and task completion. In our agent execution engineering layer, we are doing the execution and context well, but we still need some multiple steps and some kind of graph or orchestration. So in this layer of agent execution engineering, we basically define how one attempt of agent works. But then loop engineering has been introduced, that you can imagine loops exist like forever. So what's new about it? But they say loop engineering defines what happens when that attempt is not good enough. So basically, when it's not good enough, you have to just tell the agent what should be evaluated, what should be continued, what kind of retries, or do you want a human in the loop? So let me show you how our project works without loop and then with loop. This is our project without the loop. And this is like the intake, damage evidence, payout, human review, rejected, all of that, those nodes and the edges. And then actually the conditional edge is it just route to human or rejected or auto approve it, and then end, which is like kind of staying there and deciding it just one time. And if we do it with loop, we basically add the damage attempts. It can be 20 if you want to. Loop evaluation, a damage loop decision, and then we come to our graph builder where we evaluate, and then you have this router, and it's working like this. This we have all of the nodes, and at the edges, we have conditional edges, and it does that evaluate damage, and it just say if damage loop decision, it does it in a kind of loop. And the same for router. So it's always just kind of looping it inside that graph until this condition has been met. By the way, if you want to build real-world AI agents, you can find my free 30 minutes AI agent deep dive and 2 practical guides in the first link in the description. In other words, loop engineering is where we get feedback loops that verify, trigger, and improve agentic system. And main question is how agents get better over time. In the first loop that we have, just loop 1, we do the task. This is the task, the same as you have seen it. And we do some action or an observation that always existed. Then we have loop 2 when we have a kind of verification, retry with feedback until criteria pass. And then we have a kind of loop 3. This is more advanced and like event driven. So the system runs again whenever the new work arrives. So you're just kind of updating itself. And the 4 is when you improve by like hill climbing loop. It means feedback from many runs, improving future runs as a pattern. So loop engineering is more cross-cutting. It spans agent execution, orchestration, harness, production system, everything you want actually everywhere to have this feedback loop. So you can see that they also can work together and get back to each of the internal loops or previous loops. It's a kind of hierarchy from very detailed to very high level. It also fits these design patterns. I've shown you guys 9 patterns in my video about tax and accounting and 6 about LinkedIn project. Both of them are end-to-end projects. And this is like in the tier 3, you have also these critic actor or evaluators or self-healing or human in the loop. And if you want to understand where does it fits with loop engineering, these are our patterns. They are basically in the loop 2. In loop 1, is kind of have always the model tools and doing a task. But in loop 2, we do the verification and these kind of grader and evaluation. And all of these evaluators or critic or actors or self-healing are kind of in that level. So design patterns tell you what local feedback mechanism to use. Loop engineering tells you how feedback works across the whole agentic system. Another thing that I want to show you about the loop engineering is from Andrew Ng, which is like kind of using loops for building 0 to 1 products. A very prominent figure in AI. Andrew has been always for building products like in a prototype, very small one, and then making it bigger and bigger. And this is also in the loop. So you start with agentic coding loop. You spend a few minutes coding, writing the code, run and test it, and check it in the browser, iterate it until the spec is met. So if we have like BMAD or plan mode or superpowers or any of those skills, I have it in my skills video. That's the part where we try to meet those specs. In the second loop, we have more developer feedback loop. So we have review the product and then give feedback. And then we have this update spec and priorities. So we are going to get back to our priorities and just kind of update them. So you can see it also get back to the first one And we do run it again and see what's the result. In the third or external one, you can go ahead and use the usage data and feedback of the people and then refine the product vision. As you can see, we go on higher level. So it's kind of product A/B testing, alpha testers in the second one, and friends at the top. This is how also a product vision can work when you're building like an app from your end-to-end production agents. So first one is faster looping. Second one is kind of middle looping. And the last one is the slowest one. So the fastest one, you run it every few minutes. The second one, you run it every 10 minutes to hours. And the last one, basically hours to days to weeks, because you don't have that much of feedback all the time. You want just kind of get the patterns. So you remember I told you loop engineering is going to surprise you. What I meant by that is it is everywhere, from prompt engineering to production agent engineering. In every place, the shape of it will look different, as I gave you just some extensive examples, but it is everywhere to improve and basically use the feedback as a pattern and make our agentic system better. So next one, we are talking about graph for orchestration engineering. If you remember, I've shown you for the insurance this graph of LangGraph. So we have intake, damage, evaluate. Then it goes to continue to policy risk, payouts, and router. And every time from the evaluate, you get the human review. If it's good enough, it goes to end. And router as well, rejected, auto improve. And if it's not good enough in the human review, retry actually happening here. So as you can see, we kind of already building a graph. And that graph for orchestration, when you're just kind of using supervisor or aggregator or human approval, that's for better coordination. But the limitation of this is that the structure alone does not ensure reliability. So what we have here, we can also have this graph engineering where we connect the knowledge. So we have the graph of agents itself, and it just kind of follow the execution flow. But the graph engineering just kind of have these knowledge and memory graph. The most important one in the community, we have GraphRAGs and the graph memories. So GraphRAG from Microsoft is one of those, like using chunking, extracting entities, building clusters of community detection, and then summarizing those community and answering. Then we have graph memory. So it's just kind of showing over time what are the connections that where I work as Mariam, for example, and then the facts can change actually over time. And then we have, for example, for our insurance decision policies, could be old policies, and then we make it new policies. And next to GraphRAG, lazy GraphRAG, HippoRAG2, and in 2026, we have some trends where it's around lazy indexing, agentic traversal, and small type edges. So we basically improve that GraphRAG type of working with the information. And the best retrieval nowadays is hybrid, so not graph only. And when do graph wins? When you have multi-hop, you have temporal, you have time sensitivity and synthesis. But when you have just a simple lookup, or the cost is important, it's important to just keep it to the normal one and not the graph. And just remember that bad entity resolution, if you don't have the names completely the same, then it can also break multi-hop trust. So use graph for orchestration, as I showed you, always. But for knowledge, always selectively and know what you're connecting, because it's pretty intense. I've done graph analysis for fraud detection for about 5 years. It's quite computationally expensive to build graphs. You should use a lot of lazy approach, so not build the whole graph, but just build the pieces that you need. So we've talked about graph engineering. Another term which is very important is harness engineering. When it comes to harness engineering, I would say one of the most important thing is evals, evaluations. So let me show you a few of those evals for the insurance claim agent. I have built like 72 evals. It's, as you can see, test image mismatch, test low confidence triggers, test score, test risk score for escalation, not escalation, then invalid policy triggers escalation, then excluded coverage, payout above limit, payout below limit. So you can see it's a lot of different evals and audit trail checks that has been done for this system. The complete walkthrough is in that video, and there are more of them in the test risks, test policy, test payout, and test image claim match. So harness is about getting an input, having some pre-flight, some validation, agent orchestration, post-flight, so again, some validations, and then giving that answer. So we have all of these runtime policies, retries, observability, state management, everything that we have just kind of built up from the context engineering and above when around execution, just adding those logging and metrics and dashboards and alerts and audits and human in the loop and secrets, all of that together is basically our harness, because we want to control the complete execution. That's harness engineering. Because how do we make execution reliable, controlled, and observable around agent and graphs? That's actually our harness engineering. We want this safe execution. We want predictability. Because nowadays, it is not anymore about what you built, because the code is getting faster and faster by Cloud Code and Codex. It's more of, do we reach the point that business has asked us to? We want to build production AI agents. Do we deliver on what they want in the enterprises or other companies? I also use this idea when building medical AI agents. We code 5 different plugins, a specification planning plugins, and then I had LLM as a judge. And for that, I used 13 different criteria, production criteria, which brings us to the next phase, which is production agent engineering. This is where all the previous layers become one usable business system. It just fit into a real workflow and show evidence and create a traceable final decision. So basically, production agents means integrating the agent system with real business workflow, like having harness, business system, governance, and reliability, all of them together. So it's having the user and channels, like business app, agent harnesses in the middle, enterprise tools and guides. Then you have security, human in the loop, and deployment monitoring and metrics. And this way we have arrived at our 6th and last step. But you have seen me explaining all of these steps. If you wanted to be also executed with all of the walkthrough of the insurance claim that I showed some of the code snips, you can watch it in this video. I see you there.